Welcome to FEI TV. I'm your host, Dan Feinberg, and I'm joined today by Cliff Matheson. Welcome, Cliff.
Thanks, Dan.
Cliff's an application engineer who's going to talk to us today about particle sizing, analysis, and morphology. What exactly is the problem that we're trying to solve?
So in a lot of today's major industries, they use particles in their final products. So understanding not only the particle size, but also the morphology of these particles is very important to people doing research in those industries. For instance, in the pharmaceutical industry, understanding the particle size and morphology and making sure that they're correct is going to really affect the final outcome of the product. So in the pharmaceutical application, it may affect the bioavailability of the final product.
Well, that sounds important. What other examples in other industries can you give us?
So also in the food and cosmetic industry, particle research is important as well. So the morphology and particle size may affect the shelf life or the texture of the final product.
So research scientists and quality engineers both need to be doing this in these industries. How do they go about doing it?
Well, traditionally they're going to use two tools to accomplish these tasks. The first tool is a particle size analyzer, and that's going to basically just give them particle size data. The second tool is for understanding the morphology of these particles, and traditionally for that you're going to use a scanning electron microscope, especially since a lot of today's particles are getting very small, much below 1 micron in size.
So we're talking about expensive, specialized, complex tools that require different types of expertise to operate. We have a better way with Phenom. Can you tell us a little bit about that?
Well, we absolutely do have a better way. The Phenom is a tabletop SEM, so it's going to give you that morphology data that a traditional SEM would. However, you can also use the files that are captured with the Phenom and use those in conjunction with a off-the-shelf particle sizing software to actually get particle size data about your samples.
So what type of software is this exactly?
So there are several different types of software. There's open source software such as ImageJ that's available free online that you can actually use for particle size analysis. And there are also some more advanced applications and software platforms as well, such as Scandium, which is available off the shelf through Olympus.
Wow, that's exciting. Now I see you've queued up an image here. Can you tell us a little bit about it?
Sure. So this is a scanning electron image of several small particles. Now, most of these particles are about a micron in diameter. There are two things to pay attention to. So the first is the morphology. Now, we get morphology on this image as we would with any other SEM. So we can see that typically a lot of the particles in here are spherical in shape. However, we also have some outliers here as well. Particles like this one and this one here are not spherical in shape, and these may cause problems in a lot of today's products that use particles. Now, the other thing to pay attention to is there's also some variance in the size of these particles. So there's some larger particles here and here, as well as here. However, there are also some smaller particles. So even with the naked eye, you can see that there is variance among these particles. Now, just looking at them quickly, you're not going to be able to get any statistical data out of that. However, you can take this image, which is stored with a TIFF header, plug it into one of these off-the-shelf software platforms, and actually get statistically meaningful data out of them.
That's really exciting. So you get the best of both worlds with Phenom.
Absolutely.
So how would you summarize the advantages of using Phenom over that older method?
So the Phenom's basically going to give you the power of having your morphology and particle sizing and doing that with one tool rather than having two tools, which conventionally would be the answer for most researchers.
That's really terrific, Cliff. Thanks a lot. And thank you for joining us on FEI TV.